Hello and welcome to Maths with Jacob. This lesson will focus on trigonometry and we'll be looking at some very special ratios. As always, a special puzzle to warm up the brain cells is on the next slide. The answer will be given at the end. Enjoy. What is the meaning of the following? Good luck with it. See how you go. Special trigonometric ratios. 30 degrees, 60 degrees and 45 degrees. You'll notice here I've drawn an equilateral triangle. Each side of the equilateral triangle is 2 units long. I have a perpendicular here which makes this side 1 and that side 1 there, but altogether 2 units long. Now, as a result, because it's an equilateral triangle, that's 60 degrees obviously, so is that. Because this dotted line bisects that angle, that's 30 degrees. Now, using Pythagoras' theorem, the length of this perpendicular here is the square root of 3. So we can use this triangle to work out some very special ratios. And here we go. For example, the sine of 30 is a half, because sine of 30 is opposite over hypotenuse, so that's why it's a half. The cos of 30 is the square root of 3 on 2, so cos of 30 is adjacent over hypotenuse, square root of 3 on 2. The tan of 30 is 1 over the square root of 3. Tan of 30 is opposite over adjacent, and that's why it's 1 over the square root of 3. Now, in a similar manner, if we look at 45 degrees, we come over to this triangle here, which is an isosceles triangle. So it's a right angle triangle, it's isosceles, so we have 45 degrees here and 45 degrees there. Each of those sides is 1. So again, using Pythagoras' theorem, we can work out that the hypotenuse is the square root of 2. So the sine of 45 is 1 over the square root of 2, which is opposite over hypotenuse. The cos of 45 is 1 over the square root of 2, which is adjacent over hypotenuse. And the tan of 45 is 1, opposite over adjacent. Now for 60 degrees, we come back to this diagram. Sine 60, opposite over hypotenuse, square root of 3 on 2. Cos of 60, adjacent over hypotenuse, which is a half. And tan of 60, opposite over adjacent, which is the square root of 3. Now some more trigonometric ratios. These are reasonably special, these ones. 0, 90 and 180. And here are the answers for each of them. Sine 0 is, that's sine 0 degrees is 0, cos 0 degrees is 1, and the tan of 0 degrees is 0. The sine of 90 degrees is 1, the cos of 90 degrees is 0, and the tan of 90 degrees is not defined. The sine of 180 degrees is 0. The cos of 180 degrees is minus 1 or negative 1. And the tan of 180 degrees is 0. These come in very handy when you're drawing graphs. Some more useful ratios relating to sine, cos and tan. Here we have a right angle triangle. The height is A, the base is B, and the hypotenuse is C. If that's theta, that must be 90 minus theta, because that angle and that angle both add up to 90 degrees. So that must be 90 minus theta. Now we can see that sine theta is A over C. Sine of theta is opposite over hypotenuse. That's quite easy to see. The cos of 90 minus theta, which is the cos of this angle here, is adjacent over hypotenuse, which is also A over C. So we can see that the sine of theta is the cos of 90 minus theta. That means that the size of an angle is the cos of its complement. For example, the sine of 30 is the cos of 60, etc. Now, let's look at sine theta here. Sine theta is A over C, opposite over hypotenuse. Cos of theta is B over C, cos theta B over C. Okay, so sine theta is A over C, cos of theta is B over C. Let's see what happens when we have sine theta over cos theta, which is A over C, of course that's sine theta, and here we have B over C, of course that's cos theta. When dividing fractions, you inverse and multiply, so you find the reciprocal of this fraction here, which is C over B, and you multiply. When you do this multiplication, the answer is A over B, which is actually tan theta. Because look, tan theta is opposite over adjacent, so tan theta is A over B. So what have we learnt from this? We've learnt that sine theta over cos theta is exactly the same as tan theta. Finally, here is a very, very important identity. Sine squared theta plus cos squared theta. Sine squared theta is A squared on C squared. Cos squared theta is B squared on C squared. When you add those two fractions together, you're allowed to add the numerators together because the denominators are the same. So that's A squared plus B squared on C squared. Now we know from Pythagoras' theorem that A squared plus B squared is C squared. So C squared over C squared is 1. So sine squared theta plus cos squared theta equals 1. That's one of the most important trigonometric identities you'll see, and it helps you work out a lot of problems. Just summarising the previous slide, the sine of theta is the cos of 90 minus theta. Sine theta over cos theta is tan theta. And sine squared theta plus cos squared theta equals 1. They are very useful identities. Here's a quick quiz. Please check through the video at any time to help you. This is the puzzle. What is the meaning of the following? And the answer is foreign aid. I've put that there to give you a little hint. I think you'll be able to see that if you look at it carefully. Here are the answers to the quick quiz, and please check through the video at any time. If you enjoyed this video, please subscribe on the next slide and you'll receive a notification as to when the next video is available. Hope to see you next lesson.